Good morning, everyone, and welcome back to the class of 3201. So in our previous lectures, we have already covered these components of module 3, the ArcGIS, vector representation in ArcGIS, spatial data models, and from spatial data models, we talked about topology in last class. Now, what left is the spatial relationship and finally the scales. So spatial relationship, it identifies in topology how the things are located. So we can say that, right, sorry. Okay. So we can identify that one feature is within another feature. For example, A is within B. We can say whether they touch each other. So A is touching B. Here is 2 polygons, and here is another example of 1 polygon touching a line, and whether 2 lines are crossing each other, or 1 line is crossing a polygon, or maybe they are overlapping. Okay, so something like that. Also, when we do that, we have to keep in mind that a geometry cannot contain another geometry of higher dimension. That means a line cannot contain a polygon. A point cannot contain a line because the line is of higher dimension than a point, or a polygon is a higher dimension of a line. So, however, the reverse can be possible. That means a line can be within a polygon, or a point or multiple points can be within a polygon or within a line. Okay, that reverse, the opposite is possible, but it's not reciprocal. So that means, the opposites of opposite is not possible. So now we are talking about scales, the final topic of module 3. But before we talk about scale, I would like to write down something to draw an outline of the things that we are going to discuss today. And so the first thing that we have to talk about is the data. Okay, and whenever we are data and location, maybe. Okay, so from this data, we have to identify the data source, whether it's primary or secondary. So primary or secondary. So from this primary and secondary, then we have to identify that what is the characteristics that the data is identifying. So from this data, we then further again, what we can do is we can go on. So that means what sort of geographical problems that it is dealing with. So we can say it's explicitly geographic. Explicitly, I think there is no E, and we can say it's implicitly geographic. Okay, so or implicitly spatial or geographic, but let's say spatial. Okay, so they're spatial. Explicitly or implicitly spatial, and then we say that, okay, so how are they going to, combine? Is there anything going on? So third one, that is the aggregation. Okay, so here it would be no, I think we do not need these lines. Okay, you can simply write aggregation And from this aggregation raises a concern of ecological fallacy. Okay, so there you go. We have the problem. So this is a problem. Okay, problem ecological fallacy that concerning about the aggregation. And finally, what you can say is, all right, how about the variables that we are using? Okay, so let's go back here. Variables. So variables, they can be of two types: discrete and then continuous. Okay, and when we do that, and another type could be qualitative. And quantitative. So now this discrete, continuous, qualitative, and quantitative, all of them deals with scale. Okay, so the scale is further divided into, let me write it down here because I do not have space. Okay, so this thing is becoming scale. This is not T, that is L. So its scale is then nominal, ordinal, interval, and ratio. Okay, we have these four classes of scale: nominal, ordinal, and the ratio. And so from here we have to we derive to another concepts. So concepts that we get here are, right, I think I can draw this. So it's the precision, accuracy, validity, and finally reliability. L-I-A-B-I-L-I-T-Y, reliability. Okay, so anyone have any questions so far? So this is our map of today. Okay, so firstly, the data. Okay, so whenever we talk about GIS or whenever we talk about anything, what is that we are really talking about? We are talking about any geographic problem, right? There is a problem that we would like to solve. So for this problem, for this geographic problem, the first thing that we do, I mean, to solve any problem, what do we need? We need data. We have to have access to data. If we do not have access to data, then no problem can be solved because we do not have basis for measurement or basis to get any idea about the insight of the problem. So what we do is we collect the data. So while collecting data, so this is collection. Okay. Collection methods. So while collecting this data, we focus, we have two types of data that we have access to. One is the primary data, another one is the secondary data. In primary data, it's a little bit difficult to collect because you have to go to the field, you have to expend, manpower. It could be expense of money, it could be expense of time, and so on. On the other hand, the secondary data collections are fairly easier. Okay, it's you have to pay someone to get the data, or you can download it from another source. So it's fairly easy. Okay, so and also there is another dimension of the geographic problems, or another dimension of the data that helps us to solve the geographic problems. So whether the data is explicitly spatial or implicitly spatial. And what do I mean by this explicitness and implicitness? So explicitly spatial means the data not only talking about the data, but also talks about the location. All right, so it considers location into your study area. All right, so when you are, for example, I'm going to give you one example. It would be fair, easier, I think. So for example, you are working in Pizza Hut as a GIS expert, and you would like to open new Pizza Hut. Okay, there are lots of Pizza Hut in Dhaka. Let's talk about Domino's. Okay, you want to open up a new branch of Domino's in Dhaka. So in Western countries, when you go and buy different services, for example, or foods, sometimes what they ask you is, what's your postcode? All right. So when they ask you about your postcode, then I have to draw something. Let me see. Maybe I can draw in this place here. So for example, in this instance, you ask the staff of Domino's to collect the addresses, right, or the ward numbers of their consumers or customers. So you are in Dhanmondi, so that's Dhanmondi Pizza Hut, sorry, Domino's, and then the staff, they are asking about the locations of their customers. So the customer saying that, okay, I'm from Mirpur 12, I'm from Mirpur 10, I'm from Mirpur 1, I'm from Mirpur 13, I'm from Mirpur 14, I'm from the Kalshi, I'm from ECB, I'm from BUP, I'm from DOHS, I'm from Kazipara, Sheorapara, and so on. Okay, so, and you are thinking that, okay, so I'm going to open one Domino's in, it's raining, so there might be some background noises. So you are saying that I would like to open one Domino's in region of Mirpur. So you take the data of the customers. So you take their locations. So from locations, now you have X and Y coordinates. Okay, you have X and Y coordinates of each wards maybe, or the name of the localities. Then what you do is, now you have to open one branch which would be serving for all these customers, or serving all these customers. So what if, without considering any GIS analysis, you say that, okay, let's open up one in Sheorapara. Okay, because I don't know, Sheorapara is somewhere at the beginning of this region. So let's open up here. Okay, so you open up one Pizza Hut here, or you can say that, all right, how about we do not open it here, let's open in DOHS. Okay, because it's a fairly enclosed community and it's close to Mirpur 12 and all this region. Okay, so might be, it might be good for us. So you might consider that, all right, let's open up here. Or you might say that, okay, so let's consider the population density and other services that are available. So let's open up in Mirpur 1, okay, or Mirpur 2, something like that. So you say that you have three potential locations, all right? based on different considerations that you have made without considering the location, without considering any consideration to the X and Y. Now, this solution has some problems. Why? What problems? Those who are in ECB, okay, they will not come to your Domino's if you open up in Mirpur 1. I mean, you will be losing a large number of customers. Those who are living in Sharapara, they will not come to the Domino's located in DOHS. I mean, a large portion of customers will rather go to Dhanmondi maybe, okay? But then the purpose of opening a Domino's here is to serve these people, okay? So similarly, conversely, if you open in Sharapara, many who are in ECB and then in DOHS, they might not come to this place. They might go somewhere else because there are traffic jams and other things to consider. So how can we solve this problem? One solution could be the center of gravity. Center of gravity. Okay, and what is that? That's the mean center. And what's the mean center? Well, this is what I teach in masters. However, to put it simply, you take the coordinates of all these locations. So you get X and you calculate the mean of X coordinates and you calculate the mean of Y coordinates. So mean means average, all right? You calculate the average of X coordinates. How to do that? For example, your coordinates are, let's say 1, 2, 3, 4. So you have Y is 1, 2, 3, 4. So this is a pair of coordinate. This 2, 2 is a pair of coordinate. 3, 3 is a pair of coordinate. So now if you sum all the X values, you get 3, 3, 6, 10. So 10 divided by 4 is 2.5. Okay. So similarly, Y has 1 plus 2 is 3, 3, 6, 4 is 10. So divided by 4, number of samples is 2.5. So you calculate the average of X coordinates and average of Y coordinates. If you do that and if you map it out, you will realize that this is the center of all these locations. So that means you find a potential site where you can open up your Domino's. That Domino's will serve all these locations. So when you open up these Domino's, these customers, they will be coming to your Domino's instead of going the other branches located in outside of your concerned region. Okay, so this study, since it's considering the locational values explicitly into the study, these are, we can say, these are explicitly spatial problem and explicitly spatial studies. The implicit means when you talk about the implicitly spatial problem, it does not directly take the location into the account. However, the location does have some influence on it. One quick example could be the flood scenario or the riverbank erosion. So in recent floods, we have seen the many videos got circulated on social media about the riverbanks being eroded and many infrastructures are being lost into the rivers. And if you look into the study on the floods and the riverbank erosions, you will find that mostly the left side of Padma is highly eroded than the right side of Padma, except few areas, few localities. Okay, so by considering, so now, in fact, for example, let's say that you do not know that. So you want to do a research. You want to find out which side of the river is more vulnerable to riverbank erosion, or is there any differences between the effects of riverbank erosion on the two banks of the rivers? Okay, So now when you are saying that is there any differences between the two riverbanks, you are not explicitly considering the location, their location, rather you are more concerned about the riverbanks or amount of erosions. Okay. However, implicitly you are relying on the location. So indirectly you are indicating towards the location. Okay. But your main concern is not location, rather is the riverbank erosion. এই জিনিসটা কি বুঝতে পারলে? কারো কি কোনো প্রশ্ন আছে? Anyone have any question? Okay.
স্যার এক্সপ্লিসিট কি স্যার আমরা তাহলে ডাইরেক্ট রিলেশন বলতে পারি আর ইমপ্লিসিট ইনডাইরেক্ট রিলেশন বলতে পারি?
হ্যাঁ, সেটা বলা যায়। But this explicitly special and implicitly special are I mean they are terms.
Okay sir.
Okay, তো সেই জন্য আমরা explicitly and implicitly বলছি। Okay, so all right, so next one is the aggregation, right? So in aggregation, the aggregation could result into some sorts of error. So one example is the deduction error or ecological fallacy. And what do I mean by aggregation? So in geography related study, another issue that we deal with is the aggregation. What's that? The issue that we deal with is the aggregation. And how, for example, you would like to do, I mean, many people are doing study on the people's awareness of COVID-19, right? So when they are doing that, they are not considering, I mean, this is not neither explicitly special study nor implicitly special study. Because when you are doing it, you are not really saying that I'm doing only in Dhaka, I'm not doing from perspective of divisional categories or at district level. So আমি যেটা বলছি সেটা হচ্ছে আমরা যখন এই COVID-19 এর অ্যাওয়ারনেস, লোকজনের অ্যাওয়ারনেস নিয়ে যখন গবেষণা হচ্ছে, তখন কেউ ডিস্ট্রিক্ট লেভেলেও কাজ করছে না, ডিভিশনাল লেভেলেও কাজ করছে না, রাদার তারা কোনো স্পেশাল অর্থাৎ এরিয়া বা জিওগ্রাফি নিয়ে কোনো কিছুই বলছে না, তারা শুধু বলছে যে অ্যাওয়ারনেস লেভেল ইন বাংলাদেশ। However, that operational definition has some errors. So এই যে বলছি operational definition, here is one more term. Definition. Okay, this one is related to validity. All right. This is related to validity. আমরা এখানে আসবো একটু পরে। So why they have this problem with this by saying it's for entire Bangladesh? Because the responses that you are getting, they are not from all over the country. So how can you say that it's for entire country? Okay, most of the responses that you are getting are from Dhaka. And then there are some responses from Kumilla, some responses from Jashore, some responses from Satkhira, some responses from Rajshahi, some from Sylhet. And that's it. How about Panchgor? How about Bhola? How about Teknaf? No one responded from that region. So if you now 80% or 75% of your responses are from Dhaka and 25% are scattered all over the country from different regions, can we really say that this study represents the entire country? We cannot. Okay, because it's heavily tilted towards Dhaka. Our result is heavily focused or heavily influenced by the the people's behavior of Dhaka city. At the same time, we are claiming that this study concerns of the entire country, but we failed to collect data from entire country. We did not even collect data for all districts. Okay, we failed at that point. So we cannot claim that this study represents the entire country, because at some point, maybe some, the people of TechNav, they might say that, okay, the result that it got is totally different in TechNav. And so that difference, that's disparity. So disparity মানে হচ্ছে দুটো জিনিস যদি থাকে তাদের মাঝখানে যে অসামঞ্জস্যতা। ওকে, তারা যে অসামঞ্জস্য, তারা যে এক জিনিস নয়, একই নয়, সেটা হচ্ছে disparity. So the disparity between Dhaka and Teknaf, we could say it's two poles. So if one is located in one pole, if people in Dhaka is behaving in one way, then people in Teknaf are behaving totally the opposite way. Okay, so if we have included the behaviors of Teknaf, our result could have been different. So that means we cannot claim that is for entire country, but that we are doing so. So because we are saying that it's not really explicitly special, nor it's implicitly special, we are just trying to create one impression of study of all over the country. But then when you do the geographic analysis, we cannot claim in such a way. We have to be explicit about our operational definitions, that what do we mean and where is our boundary of study area. So for example, now you have data of COVID-19 it could be the COVID-19, the data of the transmission, or it could have data of people's awareness. So for example, let's say you have data of people awareness at divisional level. So in Dhaka division, what is the condition of people's awareness? How much are they aware of this COVID-19? In Sylhet, how much are they aware? In Chittagong, how much? In Khulna, how much? In Rajshahi, how much? Rangpur, how much? Mymensingh, how much? So in that way, now you have the people's awareness at the divisional level. So now you can aggregate these results. Okay, and then you can claim that I have identified the people's awareness in Bangladesh, or community awareness of COVID-19 for Bangladesh or of Bangladesh. অর্থাৎ আমার কাছে যে ডিভিশনাল ডেটাগুলো ছিল সেগুলোকে আমি এখন যোগ করে তারপরে আমি এখন পুরো কান্ট্রির ডেটাকে আমি বলছি। অর্থাৎ যোগ করেছি মানে কি, আমি তাদেরকে অ্যাগ্রিগেট করেছি। Okay, I aggregated the divisional data, and now I'm saying that the result that I have got is representing the entire country. অর্থাৎ aggregated যে বাউন্ডারি যে ভ্যালুটা পেয়েছি এই পুরো বাউন্ডারিকে রিপ্রেজেন্ট করছে। Okay, I can say that. Now, how about, now you have data for the entire country. Let's imagine another scenario. You have data for entire country, but you cannot deduce this data into divisional level. অর্থাৎ তোমার কাছে পুরো দেশের ডেটা আছে। ওকে, তো এই যে আমরা যে স্টাডি করেছি, বললাম অনেকে স্টাডি করছে, এইভাবে স্টাডি থেকে তুমি পুরো দেশের ডেটা নিয়েছো। ওকে, একজন বলছে যে আমার পুরো বাংলাদেশের COVID-19 এর অ্যাওয়ারনেস লেভেল কি ধরনের, এই ডেটা আমার কাছে আছে। ওকে, এখন তুমি চাচ্ছ কি এই ডেটাকে তুমি এখন ডিডিউস করবা, ডিডাক্ট করে তুমি এই ডেটাকে ডিভিশনাল লেভেলে ভাগ করে দিবা। ওকে, সো এই জিনিসটা করা যাবে না। কেন? বিকজ তুমি জানো না যে কোন ডিভিশনের অবস্থা কিরকম। তুমি কোন ডিভিশনের অবস্থা কিরকম এটা দেখে তুমি পুরো দেশের অবস্থা তুমি নির্ণয় করতে পারো, নিরূপণ করতে পারো। ওকে, বাট পুরো দেশের অবস্থা থেকে তুমি ডিভিশনাল স্ট্যাটাস তুমি কনসিডার করতে পারো না। সার্টেন একটা ডিস্ট্রিক্টের তোমার যদি মর্টালিটি রেট জানা থাকে, ওই ডিস্ট্রিক্টের পার্টিকুলার একটা ফ্যামিলির মর্টালিটি রেট তুমি জানতে পারো না, আইডেন্টিফাই করতে পারো না। ওকে, বাট বাই অ্যাক্সিডেন্ট if you do that, then that would be an error, and that error is known as ecological fallacy. Okay, so we call it in another name, that is the deduction error. So deduction error, when you wrongly classify an aggregated value. You classify into multiple classes, or any geographic data. You deduce any geographic data into the next level of boundaries, geographic boundaries, and now, which is not really logical, that one is called ecological fallacy. Okay, so ecological fallacy নিয়ে কারো কোনো প্রশ্ন আছে? Okay, so now next one is the variable. So the data, when you have data, now the data is stored as variables, right? That we know that from our 2207 course. But then we try to categorize this data, or rather these variables, into different categories based on how they act. So the first one is the discrete and continuous. So the discrete, they have significant stopping point. They normally deal with the full values or integer values. For example, if you have values of, for example, you are considering the number of households, okay, or the household numbers, or the size of the household. So the size of the household is, they could be 1, 2, 3, 4, okay, because there are 4 people living in one single family. It can never be 1.5, because humans, they cannot be 1.5. Okay, so these 1, 2, 3, 4, they are discrete. Now this discrete is different than discrete objects, which we previously discussed. We are talking about data at this point, okay, statistical data. And continuous is something which we keep continuing, so it has these fractional values. For example, if you are talking about temperature, one temperature could be 30 degrees, then another temperature could be 30.5 degrees or 30.1 degrees even. Okay, 30.1. The next one could be 30.2 degrees, and so on. So this is a continuous scale. It does not have any break. Okay, it is not discrete. It continues even to the fractional level. On the other hand, based on the information that it contains, whether they are countable or uncountable, the variables that or the data that it contains, based on that, we can identify our variables that we use in our study into qualitative and quantitative. Okay, so qualitative is, there is nothing which is countable. For example, you took interview, so you cannot quantify interview. And quantitative is anything that can be counted. Okay, for example, you took rainfall data or temperature data or household data. So that one is quantitative. You can count them. They are numbers. So all these data needs to be measured, right? What is the purpose of this qualitative and quantitative? It's just to make a measurement. The discrete and the continuous, this 1, 2, 3, 4, or 30.1, 30.2, 30.3, these are values, and we want to measure them. When we would like to measure them, we have to set up some scales. So scales for qualitative values, scales for quantitative values, scales for discrete values to represent discrete values, and scales to represent the continuous values. And based on that, now we have this scale, which is also known as NOIR, N-O-I-R. So N is the nominal, O is ordinal, I is the interval, R is the ratio. Okay, so in nominal, they are simple categories. If we make any category, that is the nominal scale. Okay, and they have specific boundary. One object cannot fall into two classes or two categories. For example, you are identifying based on the age values, you are identifying that old, young, children, and middle-aged. Okay, something like that. So you are saying it's old, young, and child, for example. So you can either be either be old or young or child. At the same time, you can never be a child and young. So by this young, we are not talking about age, rather we are talking about age group, right? Okay, so young is being represented to the age from 13, maybe 13 to 45. Old is if you are above 45 or 50, if this is 50. Okay, above this range is old. And from 0, that means the date of birth, to age of 13, before 13 is child. So your age, if you are 12 years old, you are a child. If you are 12 years old and 364 days old, you are still child, you are not young. The moment you become 365 days old, you become 13 years old and you become part of this group, young group, not child anymore. Okay, so that means the categories that we define in the nominal scale. So nominal scale deals with the categories. Okay, also the word nominal comes from name. So from name comes from nominal. Nominal. All right. So anything that has name of the category, name of anything is in the nominal scale. Okay. And they have specific boundaries. These boundaries cannot be crossed, cannot be overlapped. These boundaries do not overlap. All right. So that means one data can fall into either class, not into all classes, or in either nominal scale. So ordinal depends on the ranking or seniority. So in our country, we talk about the seniority a lot. So the elders, they are more respected than the children, right? So if we talk about the seniority from this perspective, then we can say that old, these are the most senior one, most respected one. Young, okay, we will listen to them. Child, we do not really listen to them, but we take care of them. Okay, so now we are creating a ranking, and the ranking is the higher you go, the more rank you have. So that's ordinal. Okay, so ordinal deals with the ranks. So now when we're talking about ranking, the ranking is again divided into two types. One is the strongly categorized or weakly categorized. Okay, and what is the strong and the strongly ranked or weakly ranked? One example is that we read about it every day, saying that's the ranking of the university, that no Bangladesh university got within the 1,000 top ranked universities, right? So when we are talking about these top universities, we are talking about the ranking. So in this ranking, we have number 1 university, number 2 university, number 3 university, and they are exhaustive. That means number 1 is the number 1. There is no difference. There is no range between number 1. So if Harvard is the number 1 university, then it's just one single object that is number 1. Okay, that is Harvard. So this is called strong categorization or strong order or strong ranking. Okay, now for example, just imagine that you are trying to classify the population density. Okay, or you would like to classify these ranks. So this old, young, child, okay, you would like to make a classification, make an order. How are you ordering it? You are defining old is more than 60. Okay, those who are more than 60, these are old. Those who are from 13 to 59 or 60, below 60, these are young. and those who are 0 to less than 13, these are child. Okay, so that means this is weakly categorized or weakly ranked. Why? Because if your age is 12, you still belong to this rank. If your age is 5, you still belong to this rank. If your age is 60, you belong to this 61, you belong to this rank. If your age is 100 years old, you still belong to this rank. So within this rank, you have multiple classes. Whereas if it's Harvard, it's just Harvard. There is no range in between. Okay, so this is strongly categorized and this is weakly categorized inside this ordinal scale. And the next one is the interval scale and the ratio scale. So interval and ratio scale, they are almost same, except that interval does not have any absolute zero. Okay, so for example, if we're talking about temperature, so if we are talking about temperature and if we are talking about, let's say, the degree Celsius or centigrade degrees, then you have 0 degree and then you have minus degrees. So that means you have 0 degree centigrade temperature. After, I mean, if you go beyond this 0, you have minus 5 degree Celsius temperature, minus 25 degrees Celsius temperature, minus 30 degrees Celsius temperature. So 0 is not really representing these that there is no temperature at all. It's not representing that. Okay, অর্থাৎ 0 ডিগ্রি টেম্পারেচার সেলসিয়াস টেম্পারেচার আমাদেরকে পরম তাপমাত্রা নিয়ে যাচ্ছে না, বলছে না যে 0 ডিগ্রি মানে কি। Normally we sense that 0 means is the absence, right? So if it's 0 degrees Celsius, then we're supposed to think that there is no temperature, no heat. That's why it's 0. But in reality, there is actually heat. It's not really 0. So that is called interval. It only considers the interval between the values. So minus 25 to minus 24, minus 24 to minus 23, minus 23 to 0. So these are the intervals. They have set intervals. There are the intervals of 1 degrees. Okay, so if you consider the differences between these minus 25 to 0 degrees and 0 to 25 degrees, by interval, by the distance, they are same. Okay, they are same, but the temperature or the heat might not be the same. How is that? I'm going to explain it with the ratio. Okay, because it does not have any absolute 0, that's why it cannot identify the ratios, the differences. For example, the ratio has absolute 0. Okay, so absolute 0 means, for example, height or age. Okay, let's talk about age since we are talking about age in previous examples. So age has 0. So 0 means the day you were born, started the number, the counting of your ages, right? The counting of your age. So 0 means you are not born. So 1 means now you are 1 day old, and 2 days old, 30 years old, and so on. So there is nothing negative. You can never be minus 30 years old. So that means ratio scale has absolute 0. So since it has absolute 0, now it can actually identify whether something is twice of something else. For example, if you say, you can never say that 50 degrees Celsius is the twice of 25 degrees Celsius. You can never say that. Okay, 50 degrees Celsius is the twice of 25 degrees Celsius. You can never say that. You, of course, could say that there are 25 intervals. That means 25 differences That means if you subtract 25 degrees Celsius from 50 degrees Celsius, you will get 25 degrees Celsius, something like that. So some mathematical operations can be done. However, you can never say that 50 degree is twice of 25 degrees Celsius, and 25 degree is the twice of 0 degrees Celsius. I mean, if you have 0, 25, and 50 degrees Celsius, 3 readings, you cannot say that my reading number 2 is that twice of this 0, and number 3 is the twice of 25 degrees Celsius. You cannot say that. But if you have ages, if someone is 50 years old and another person is 25 years old, you can draw a ratio between them, and you can say the second person is twice older than the first person because they have absolute 0. Okay, so having this absolute 0 value enabled us to making this ratio, and that's why this scale is known as ratio scale. All right. So so far, does anyone have any question? If no one has any question, I'm going to erase this slide. So this is the last chance of asking any question. কারো কোনো প্রশ্ন না থাকলে আমি এটা মুছে দিচ্ছি. Okay, because I need to draw some more diagrams to it. Okay. All right. So now, within these scales, we have reached to the concepts of measurements or measurement concepts, which are 4 things. One is precision, precision, right? Accuracy. Then I said, what was that? Validity and reliability. Okay. So first off, these 2 things are connected. And what do we mean by that? If you search for precision and accuracy in GIS, you will get these examples of these data being precise, these diagrams. Okay, so let me draw these diagrams again. I think I made it too flattened. For example, you have, these are your, you know, we do the target practice, right? In the different shooting competitions. So these are the targets, or even in darts. So this is the center. Okay, this is our bullseye. That's our bullseye. We want to hit the bullseye. Then people started shooting. So some person got very close to bullseye. Some person got a little bit off the bullseye. Some person got scattered. Okay, and some person got really scattered. Something like that. Some person missed some of the shots. So in our previous discussions, you know, precision is the detail, right? So if you have 30 degrees Celsius, you could say today's temperature is 30 degrees Celsius. Even if you check your weather data, they will tell you that today's temperature is 30 degrees Celsius or 31 degrees Celsius. But if you would like to be more precise, you would say today's temperature at present is 30.99 degrees Celsius. If you want to be more precise, you could say 30.109 degrees Celsius, something like that. Okay, it can goes on. So so that means the more values, the more detail that you add, we call it precise in our previous example. And accuracy is the closeness to the actual value. Okay, so the weather app is telling you that it's 30 degrees Celsius, but if you use a thermometer, okay, you find that it's 29 degrees Celsius. So the value is a little bit close. Okay, and why it's 29 degrees Celsius? Because the weather data is collecting data from some weather station. It's an international weather app. So from this weather station, it's generalizing and it's saying that at your house, the temperature is 30 degrees. But then you use the thermometer to measure the temperature at your place and you find that it's 29 degrees Celsius. So it's pretty close. It's not 100% accurate, but to some degrees it's accurate. But then in a different location, someone else in your same locality, they are measuring their temperature and they are finding it that, okay, the temperature is 25 degrees Celsius. Okay, why? Maybe in that region it rained, it has a good, somehow the temperature dropped in that region because of the microclimate could be. Okay, so the weather app is telling you 30 degrees, but the actual temperature that you got, you see, I said actual, okay, from the thermometer is 25 degrees. So it's far away from the actual temperature. So it's inaccurate, we could say that, right? So this is the concept of accuracy and the detail is the concept of precision. But in geography or in GIS, they are a little bit different. Accuracy, the concept of accuracy is still same. If this is the actual value, the bullseye, if you get close to it, that means your accuracy is higher. The farther away you go, the accuracy starts to decrease. Okay, so the farther you start to hit, the farther away from bullseye, your shots are becoming less accurate. So if you're a shooter, you're a sniper, that's your enemy's head. You want to shoot the enemy's head. Okay, but then when you start shooting in the target practice, you are hitting not the head but the surrounding areas, so your accuracy is declining. All right, so your accuracy is low, and someone else, your friend, is shooting very close to bullseye, so he has higher accuracy. All right, so that's called higher accuracy, lower accuracy, and so on. So it's a degree of accuracy. In this case, it's whether the value is accurate or not, but in this case, we are concerning the location, so it's a degree of accuracy. The precision is, however, a little different than this example. Okay. How? In geography, the precision means how close the values are repeating. That means you start hitting into that point, and then at some point you realize that all your shots are clustered in this region, okay, farther away from the accuracy. So if I think about the accuracy is not very strong, not very high, but then all your shots are clustered together. Okay, so that means all your shots are quite precise. তার মানে আমরা যে গুলি করেছি বা তীর ছুঁড়েছি, এই তীরগুলো আমরা করেছি কি, আমরা প্রায় একই জায়গায়, অলমোস্ট একই জায়গায় হিট করতে পেরেছি। So that means my values are precise. Okay, তারা বলতে চাচ্ছে যে তারা হচ্ছে কি মানে একই জায়গায় শুট করছে, so they are quite precise. Okay, এটাকে আমরা বলছি precision. আমাদের যে রিডিং গুলো থাকবে, if they are closely clustered together, we say that this is high precision. Okay, if they are scattered, like this example, if they are scattered, then they are not precise. They do not have precision, because at one point I'm shooting at this place, I'm hitting this place, at another point I'm hitting this location, another point I'm hitting this location, another time I'm hitting this location. So I do not have any consistency in hitting. My hittings are inconsistent. Okay. However, if I have consistency in hitting, so it's the degree of consistency. How consistent am I? So that is relating to the precision. So at that point, we can say if my consistency of hitting hitting the same place is high, then we could say that it's precise. All right. So that's the precision and accuracy. So at some measurement, the measurement could be accurate and precise. For example, the data are almost close to the actual value, and also they have high consistency. So that's it has both accuracy and precision. It's highly accurate and precise. In this example, they are not precise, but they are hitting the almost close to the bullseye. So we can say that it's almost fairly accurate, but they do not have any consistency. Okay. Sorry, it's not that accurate. It's not hitting the bullseye. They are a little bit scattered in this region. So we can say that they are precise, okay, but not accurate. They are farther away from the accuracy. In this example, we can say that they are fairly accurate and fairly consistent because they are almost close to the bullseye. Okay. In this example, we can rule out everything. We can say that it's neither consistent, neither precise. Sorry, neither accurate, neither precise, nor precise. Why? Because it's not hitting the bullseye. It's nowhere close to the bullseye, so it's not accurate. It's farther away from the accuracy, actual value. Also, they are scattered all over the board, and some of them actually went outside of the board, so they are not really precise. Okay, so why are they important? Well, accuracy is important to find the actual value, to represent the actual value of the reality. And the precision is important because if I know if my data is precise, for example, if I can consistently shoot into one location, then I have to recalibrate my device. তার মানে আমি যদি কনসিস্টেন্টলি এই জায়গাটা হিট করি, আমি যদি এখন আমার ডিভাইসটাকে, ধরো সেটা বন্দুক হতে পারে বা আমার বো হতে পারে, ওকে, অর্থাৎ ধনুক হতে পারে, সেটাকে যদি আমি একটু করে ঠিক করি, অ্যাঙ্গেলগুলো ঠিক করলেই তখন এভরিথিং দে উইল বি শিফটেড towards the actual location. So at that moment I know that my device needs a quick recalibration. Okay, calibrate করে এটাকে ঠিক করলে they are going to hit. I will be able to make my result precise and accurate. So these examples could be given with the examples of GPS. You have GPS readings, and in GPS readings, if you take, before using that GPS, you have to calibrate your device. You have to check whether the device is giving you the consistent, that means whether the GIS data is giving you the consistent values or not, and also how accurate they are, their accuracy. Okay, if they are not accurate but they are quite precise, you can still take the data, and then finally later on you can fix it by moving the points towards the more actual location. All right, so that there goes precision and accuracy. The validity and reliability is also important. So validity discusses with the operational definitions. So for example, flood or temperature is highly defined or globally accepted in the community, right? Or in the global community. So what is flood? When the riverbanks, overflows and the water intrude the local community, we say it, and it remains there for some time, we say is flood. So there are already devised definition in the study globally. Okay. However, sometimes, for example, now you are working with the heat wave. You are trying to find out the relationships. Is there any relationship between the heat wave and the health complexities or the mortality rate? তার মানে বেশি গরম পড়লে হিট ওয়েভ হলে কি আমাদের লোকজন মারা যাচ্ছে কিনা সেটা তুমি সম্পর্ক আছে কিনা খুঁজে বের করতে চাচ্ছ। However, in Bangladesh, there is no fixed definition of heat wave. Bangladesh Meteorological Department does not identify, does not give any definition for heat wave. And globally, different countries and different organizations gives different definitions of heat wave. Some of them says that if the temperature is more than 35 degrees Celsius, that would be heat wave. Some of them say that it does not say about this actual temperature, that is the air temperature. That's the dry bulb temperature that we say, that is the air, without considering without taking the water vapor content, that means humidity, into the account. Because if it gets more humid, you will feel more discomfort. All right. So if it's dry and 35 degrees, but if it's humid and 35 degrees, that humid weather will give you more discomfort. So, right. So some of them, other definitions, they include the vapor content. VOUR, vapor content or humidity into the account while defining this heat wave. And in many definitions, many organizations also say that it has to be continuously more than 3 days. Okay, so suddenly if one day the temperature rise to 35 degrees and the next day it becomes 30 degrees again, we would not consider it as heat waves. All right, it has to be continuously for 3 days, above 35 degrees continuously for 3 days. So you see, we have got now 3 different definitions. One definition is concerning only with these 35 degrees. The second definition is these two. This is the second definition. And the third definition is these two. This is number 3 definitions. So you are studying the heat wave in Bangladesh, and Bangladesh does not have any definition. So you have to now devise your own definition. How would you like to define heat wave? So you say that, okay, by judging or by studying all these definitions, and Bangladesh is quite humid country, so I'm going to consider that it has to be more than 35 degrees Celsius. It has to be more than 65% relative humidity, and it has to be continuously more than 2 days. Okay, and with these 3 parameters, now I'm saying that this is my heat wave. If I see some phenomena like these, then those phenomena will be considered as heat waves in Bangladesh. Okay, so this is the definition only concerned or only used in your study, in your research. So we call it operational definition. Operational definition, because this definition only involved or only concerned of your study, nothing else, nowhere else. Okay, BMD is not accepting your definition. Any international organization is not accepting your definition. Only for your study, you devised this definition to identify what do you mean by heat wave. So before doing any study, that's why if you are doing not for now, let's imagine a scenario that you are doing study of heat wave in Bangladesh, but then BMD does not have any operational definitions, or BMD does not define what heat wave is in Bangladesh. And then without defining these operational definitions, you are conducting your study on heat wave. So without identifying this or defining these operational definitions, you are conducting your study, and now you have multiple problems. What sort of data should I collect? Okay, what should be my objective about? How can I identify heat wave? So all these big questions are coming up because you do not have any definition. You do not know what a heat wave is. All right. So if your definition, operational definition involves these three categories, you at that moment you have to collect the maximum temperature data, you have to collect the water vapor content or vapor content data, and you have to collect the time series data of temperature. That means you have every day's temperature data to identify whether the data or the temperature is continuously above 35 degrees Celsius or not. Okay, but if you do not identify these definitions, you are now at loss. You do not know what to do. So you are working blindly. And if you are working blindly, your result might have some problems. Okay, so identifying these operational definitions, if necessary, is called validity. Okay, the validity does not mean in the measurement concept, validity does not mean whether to check that your result is valid or not. Rather, to able to define these operational definitions that are vital for your study. Now, reliability, the next topic. So reliability concerns of how reliable your study is. Okay, so that means how consistent are you with your data? So that means that brings us the example of these which I gave earlier about, also it was about the third question of 3205. Okay, so in 3205 there were Landsat 5, Landsat 7 and Sentinel data that the student was using Sentinel-2 data. Okay, so Landsat 5 has 30 meters spatial resolution, Landsat 7 has 30 meters spatial resolution, but Sentinel has 10 meters spatial resolution. And if you do that, now you are getting into some problems. What problem? Because, as I said earlier about the examples of BFD, that at some point in some study reported that Bangladesh has lost a significant amount in Sundarbans. So significant deforestation happened in Sundarban, okay, after 2015. Why? Because before that, all the study were done using Landsat, so it's of 30 meters resolution. But then when the study was done in Sentinel, they were done in 10 meters resolution, spatial resolutions. So now they can in more detail, it can identify the boundaries of the forest. All right. So similarly, in the question number 3, if the student uses Sentinel-2 data for 2020, it can in more detail, it can identify the boundaries of different land covers, which might not comply with previous results or the results of the previous years. So the data that I'm considering or the properties of the data that I'm considering, they are not consistent. They are not same throughout the study. At some point, they are consistent for 2 different years, but when I come to the later years, they get inconsistent. Okay, 30 meters and 10 meters, huge difference. So that is called reliability. So reliability talks about that your study have to have consistency in terms of data. All right, anyone have any question? Okay, so if no one has any question, that's all for today. Thank you. I'm going to stop the recording now.